Okay. Let us start. Good morning to everyone. Students, very good morning. Today I am going to deliver the Unit 5 device driver concept. So, first of all we want to know what is device driver. So, the device driver is the small piece of software you are going to use it in your application software which will connect to the external of the text. Maybe it is a mouse or your keyboard or hard disk or printer. So, whichever I want to connect external to the system, I need the communication bus. So, that is why we are using the driver module. So, the driver will be embedded into my system or laptop. So, for this if you want to run the driver module, you require the small piece of software. So, that is called as a device driver concept. So, under this device driver concept, you have to categorize what are the software is required to run this one. So, normally in all the systems you have three category of software will be there: application software, system software and utility software. So, what we are going to do for the device driver will be comes under the system software, because under the system software you have the device driver concept module software will be there, and whichever the application I want to run, that software will be there, and whichever the port you want to run, so all the software will be there in the system software. And what is the utility software mean? To safeguard the system, some antivirus software will be loaded in the our laptop or the PC. And another one is the application software, whichever you want to run, maybe a Photoshop or CorelDRAW or Paint, any application, if that software will be there. So, all will be together there in my software module of the systems. Okay. So, this is the concept behind the device driver. So, then the category of the device driver, you have the three classification of the device driver concept will be there. What is the three classification of device driver? Then maybe you have the doubt what is the three classification. Even though you are connecting external the driver device module to the systems, but in which way you are going to connect, whether it is a wired system or wireless system, and what type of data is transferring from the system to the device you want to know. So, in that way you have the three classifications. What are the three classification mean? You have the character type device driver, and then the system type device driver, and then the block type device driver, and Ethernet, that is the network type device driver. So, normally you have the three classification will be there in the device driver module. So, the device driver have the character type device driver, and then the block type device driver and network type device driver. So, what is the character type device driver? So, the character type device driver mean whenever I want to use for my serial port or parallel port or sound card or keyboard, because in that way the data is not a fixed size, I am going to transfer the character by character. I am going to transfer the character by character. So, that time you have to use the character type device driver. You have to use the character type device driver. So, the serial port communication when I am going to use, maybe it is a RS-232 cable or RS-485 cable, I am transferring the data is a character type device driver. So, even when I am using the keyboard or I am going to use the sound card, you need the small piece of software that will be embedded in my system. That is why whenever I am connecting my speaker or my keyboard, it will start installation successfully. So, that is the concept behind the character type device driver. And what is the next classification mean? The next classification is the block type device driver. So, for your understanding, I will tell you that clearly, students, whatever you are connecting the printer, or when I want to transfer the data, suppose if you want to transfer the data from the system or laptop to your pen drive, or from the system or laptop to your hard disk, or from the hard disk to vice versa to the system. So, the data will be transferred the bulk. The data will be transferred the bulk. So, that time you require the bulk type device driver. So, the classification is the USB camera or disk on disk or disk. If I send the character by character, you see this one, the data won't be getting properly to your hard disk or your pen drive. That is why you are move on to the block type device driver. So, that is the second classification. And next one is the network type device driver. So what is the network type device driver mean? Nowadays we are going to connect the many of the device module to your systems. You want to communicate. So that time you need that in the communication bus more than one device or more than many device through the network, or if I want to use like a hub, that time you have to use type a network device driver. So your fifth unit of the device driver module is focused on network type device driver. So what is there in this one mean? You have the I2C bus onto the Linux subsystem, on USB and watchdog timer, and then Ethernet driver, then you have the Linux serial driver. So these all will be comprised in your device driver of fifth unit module. So now before getting to the touch of your I2C bus or USB or whatever may be, I have to give little bit understanding the concept of what is serial communication and what is the communication bus system, why it is required. So the serial communication mean I am going to transfer the data through my system or laptop to the device which I connected in the character by character. So normally I think if you are done in your lab class, if I want to run my motor, if I want to display the LCD, you are using the RS-232 cable. So it is also a communication bus that will be transferring the data from your system of PC to the target which you are connected the LCD module or motor, that will transfer the data. So I can connect only the one device to the system. But if I want to connect many number of the device to this system, that time the RS-232 not sufficient. So we will move on to the RS-485 standard. So under the RS-485, I can connect maximum 32 device. I can connect maximum 32 device I can connect. So this 32 device, one node may be a master, other node may be a slaves. So and next one is that I2C bus. I2C bus is a integrated circuit. Integrated circuit. It is, I can say as a, it is under the duplex mode vice versa communication. Many nodes I can connect it in this one. So that will be given in your unit of 5th unit device driver module. And next one is the SPI, serial peripheral interface, and this is also another one, the communication bus of that this what we mean. Here I have 4 will be there, one is the master node, other 4 will be the slave node, but here the restriction is given only the 4. So whichever application require the 4 nodes, that time I can use it that one. Remaining time I can go for the whichever module I can extend more than 4. So the more than 4 mean I can use it is I2C. So the I2C is the communication bus subsystem module. The next one is the USB, universal serial bus or universal synchronous bus. So this universal serial bus or synchronous bus, just like your pen drive or the hard disk, I can transfer the data from the system to the USB. It is a one node, but what is given in your syllabus, it is a network type device driver. So the USB considered as a hub. The USB considered as a hub, maximum 127 node I can connect it. It acts as a small hub. With this I can make it as a communication from the server to the client node. So that will be the USB bus. The next one is the Ethernet. In the Ethernet I can connect it as a many of the device module. So these are the concept behind for your the device driver. So under the serial communication, these are the device driver, you have this one. Next. So this is for your understanding, I am given this one. What type of mode of communication is happen between the system to the device. If the system is there, mean the system acts as a transmitter, your external device acts as a receiver. So from the transmitter to the receiver, I can do the communication, maybe it is a one-way communication, it is like a simplex communication. If I want to communicate with the both ways, like a client server module, then it is a full way communication or both way communication. Under the full duplex communication, maybe it is a under the duplex communication, maybe it is a half duplex or it may be a full duplex communication. What is a half duplex communication mean? The transmitter will transmit all the data. Up to this the receiver has to wait. After received everything, it will send you the acknowledgement signal to the transmitter, I received all my information. That is called as a half duplex mode. Sometime maybe this will be helpful, but all the time for real time application it won't be there only. If I use for my pen drive or if I use for my hard disk, I can use it as a half duplex mode. But if I go for, I want to connect a mini node, that time I require the ANSIC signal and acknowledgement that ensure whether the data is transferred to all the node, then you require the full duplex mode communication. So whatever you are studying, that I2C, USB, Ethernet, all will be the full duplex communication. That's why when I am using the system, sometime you are getting the some updation is required or some alert message is coming to warning you. Immediately you have to respond, otherwise I will get some troubleshooting in my system. Okay, so that is the full duplex mode communications. So this slide showing that when how the data is transmitting from the transmitter to the receiver the data. So the data will be transferred zeros and one combination from the transmitter to the receiver module. Okay. So now come to the point of view, so which is there in your syllabus, I2C. I2C is the integrated circuit. So in this one I have shown for you a master and 3 of the slave nodes, which is shown with the brown color, and 2 lines are given, SDA and SCL, serial data line and serial clock line. So this is the 2-wire bus, and if I say the topology, what type of topology mean, this is the bus topology. Why mean, in this 2-wire bus topology, many number of nodes may be connect, many number of nodes can be, I can retrieve. So in this one, whatever the node is connecting, that will be asked to synchronization happen to the clock. So whenever the synchronization is happen, then only the data will be exchanging between the master to the slave node. So maximum I can connect many number of nodes here. That's why it is called as a master to the slave node communication. What is the main thing mean? Whenever the clock is synchronization is happen, that time only the data will be transmitting from the master to the slave node, or else many master also I can use it as multi-master slave also I can use it here the concept. So this is the I2C bus. So now for your understanding, I am showing here, see this one, here I am connecting this, the 4 of the node, one is the sensor, other one is the LED, other one is the ADC, other one is the EEPROM. Suppose if I am connecting for my application, I want to read the value of the temperature. Whenever I am reading the temperature value, the LED has to blink. Whenever this one, I need analog to digital conversion, that will be loaded in my memory disk. So this all the nodes are the slave node that will be controlled by the master. So in this way, it is a single master with a 4 slave will be there. So there is no restriction here. But what is the main thing here mean? When the clock will be synchronization is happen only, this all other communication will be happen. Okay, so that is one of the limited drawback here. That is the main drawback. It is one small drawback here, this one, and sometime due to this one, many of the device I am connecting, the loading effect will be happen. Even though the loading effect happen, if we connected the proper way of the capacitor, that also I can avoid. Okay, so even though for any of the device driver you have merits as well as the demerits will be there. So now what I shown you, and here you have the data rate will be there. When I am saying this one, you have to know what is the data rate. So the data rate will be in terms of megabits data rate will be there one. Okay, so depends upon the data rate only I can do the communication. So now when I told for you this one, the single master with the many slave, and what is that, how that happen? So you want to know the frame structure. So what is the frame structure mean? The frame structure will decide how my address bus will be there, what type of data, when I want to start, when I want to give acknowledgement, when I want to stop. So that is the frame structure. In any frame structure of the communication bus, you have start frame will be there, end frame will be there, then error checksum frame and acknowledgement frame will be there. So these 4 frame will be common for any of the communication subtopology. Maybe it is a I2C, or it may be a USB, or it may be a SPI, or it may be a USB CAN, LIN, FlexRay, MOST, whatever you are using that, all you have the certain frame structure will be there, but this frame structure will be common for this one. And according to this I2C, this is the frame structure according to this I2C. Under this I2C, suppose if there is no communication happen between the master to the slave or slave to the master, mean then it is in an ideal mode. In it is an ideal mode, there is no. So whenever that it started, the starting bit I have to give, the starting bit have either 0 or 1. If it is 0, mean it is still in an ideal mode. If the starting bit is 1, mean it is ready to start for doing the transaction of data communication between the transmitter to the receiver. After this I have the slave node. Why? Maybe you can ask the question why the slave node is required. Suppose if I have one master and one slave, mean it is understood that the transmitter is directly connected to the receiver. But now the case I am connecting the 4 node. One is the, I have the sensor, other one is the LED, other one is the ADC, other one is the EEPROM. So I want to know the each of the node the address. Each of the node the slave address, then only I can easily transfer the data. That's why I require the slave address. The slave address will say from transmitter to which node I am going to transfer the data. And what is the next one? The next one is the write mode or read mode, because I told that when here I am going to take it as a duplex communication. So the vice versa communication is happen between the transmitter to the receiver, receiver to the transmitter. So now if I am saying this one, I have the LED, or if I am going to use for my temperature sensor, mean it is a simplex. But if I am connecting the EEPROM, or if I am connecting any of the ADC module or any other device, then I require both side of the communication. So that time depends the transmitting, mean it is a reading, again the acknowledgement is receiving, mean it is the writing data. So the reading data and writing data you have to mention. Reading mean the 0, writing mean there is a 1. And next one is the address. So the address will be particular of the node, which address, because I have many nodes will be there, the each node how many address is required, you have to categorize it. In addition with the slave address, this address is also required. And next one is the acknowledgement. What is the acknowledgement mean? You require the acknowledgement whether the node is ready or not. Whether the node is ready or not, it will give you the handshake signal. So that's why from the node of the receiver, it will send you the acknowledgement signal to the transmitter. I am ready, you can transmit the data. So the acknowledgement bit will be required. After getting all confirmation, then only the transaction is happened between the transmitter to the receiver module, that is the data. So the data now, after this all the steps only, the data will be transferring from the transmitter module of the master to the slave. So maximum may be the 64-bit may be transmit. So depends upon how they are defined the data structure. Based on that one, it will be vary. Maybe it is a 64 or 128, or depends upon the I2C designer how it will be changed. So after received everything, again you are getting one more acknowledgement bit. Why this required mean? Every of that the data of 8-bit data, you required one acknowledgement bit. That is the 9th bit you require the acknowledgement bit to avoid the inference or to avoid any of the misconflict data, you require the acknowledgement. So that's why here I mentioned with a dotted line, again the data will be there. So up to the data of 64 bits or 128 or 1024, whatever the defined data things, in between you have the acknowledgement frame will be there. Maybe every 9th bit, 9th mean next is the 18th, next is the 27th, like that the acknowledgement bit will be there. That will ensure my data is transmitted from the master node to the slave. So after everything has happened, at last you have one more acknowledgement bit will be there, that will assure all the data is transmitted. After this the stop bit will be there, or N bit will be there. So, the stop bit and N bit will assure this communication part will be over. In addition with this, one more data is also required at your receiver side, the error checksum. The error checksum will be required to identify any of the data is a redundant data. Any of the data is redundant data, you have to use the error checksum. Normally they are going to use the cyclic redundancy code, but only for the CAN bus of your vehicle automation, the added advantage they are using the bit stepping bit. Okay, so that will be the, in addition with the CRC in US CAN bus they are using the bit stepping concept. That's why it is more security than your I2C bus. Okay,